Good evening. I'm PJ O'Neill, serving as the branch chief for STEM training in the Student Programs Directorate, and welcome to this month's Tech Talk, Endangered Species at NOAA. Tech Talks are sponsored by the U.S. Coast Guard Auxiliary, and Scouting America Sea Scout program. Tech Talks are held on the fourth Tuesday of each month at 2100 hours Eastern. That's 9 p.m. Eastern. Our next Tech Talk will be presented on June 24th, and our subject will be Sea Perch, learning about building underwater robotics and aquatic robotic competitions. Just a reminder, this Tech Talk is being recorded and will be posted to both the Sea Scout and Aux Scout YouTube channels. Please subscribe to the YouTube channels and share with your shipmates who could not join us tonight. The recorded Tech Talks make for excellent training in your Sea Scout ship or your auxiliary flotilla. So again, please like and subscribe to the YouTube channel so that you and your shipmates don't miss out on the excellent, high-quality, on-demand training. If you have questions during the Tech Talk, please type them in the Q&A box, and we'll get to all the questions at the end of the presentation. Now I'd like to hand it over to Branch Assistant Hiram Ascabi to introduce tonight's subject matter expert.
Thank you, PJ. And again, it's an honor for me to introduce a fellow NOAA employee, Miss Briana Gibbs. She is the Mid-Atlantic Large Whale Ship Strike Reduction Liaison at NOAA's Greater Atlantic Regional Fisheries Office. She holds her Bachelor's of Science in Fisheries Management from the University of Miami Rosenstiel School of Marine and Atmospheric Science, and a Bachelor's of Science in Ecology and Evolution from the University of California, Santa Barbara. Briana's passion for science is expressed through outreach and education using science communication to make science accessible to everyone. She has worked with many types of marine life, including fish, seals, and sea lions, turtles, penguins, and whales. Again, Sea Scouts and Auxiliaries.
Thank you for that introduction. Perfect. I can't see that, so I just wanted to double check. So this presentation is called North Atlantic Right Whales and Me. Again, I'm Briana Gibbs, a contractor with the NOAA Office of, the NOAA Greater Atlantic Regional Fisheries Office, which is based in Gloucester, Massachusetts. Since I am the Mid-Atlantic Large Whale Ship Strike Reduction, I'm a contractor, and I do work in Alexandria, which is just outside of DC. So I am also on the East Coast here. To dive in, I love an agenda. So who is Briana Gibbs? Kind of what am I doing here? Why am I talking to you all? Is a great place to start for these sorts of presentations I've found. We're going to talk a little bit about NOAA and its mission, in addition to North Atlantic right whales, right whale outreach, and how you can become a marine scientist if you are inspired by this discussion. And finally, we're going to wrap up with questions. So we will dive right in. To begin, I had a pretty circuitous path to NOAA. I did know from the moment that I knew that I had to have a job that I wanted to be a marine biologist. I grew up on the beaches in sunny Southern California, looking at whales from shore, from the ocean, poking around in tide pools. And that inspired just this fire in me. I was like, I want to do whatever this is. So with that, I went and pursued my Bachelor of Science at the University of California, Santa Barbara, where I did major in Ecology and Evolution. I did want to major in marine science, but thought that ecology was kind of the story of the planet and the story of our ecosystems. And marine ecology is a story that I'm very deeply interested in. So I took a lot of classes about, marine science with an emphasis in ecology. And then after my undergrad, I dove straight into my Master of Science at the University of Miami Rosenstiel School of Marine and Atmospheric Science. It has since been renamed the Rosenstiel School of Marine, Atmospheric, and Earth Science, but that's not what it was called when I went there. As you can see from the two photos, I wanted to be on the beach. I went to school on the beach anywhere I could. If I go and get a PhD, it will definitely be on the beach somewhere because I want to be as close to the ocean as possible. Now, that said, I have worked on the coast and away from the coast all over this country. Everywhere that is a star is someplace that I've worked, and I'm pretty confident these are all the states that I've worked in. I have conducted a lot of time at sea and worked at sea in both the Pacific and the Atlantic Oceans, in addition to spending time in Australia and New Zealand doing research and doing work. That said, I have held a lot of jobs since I was 14, which I'm told is the youngest that our viewers could be. I started volunteering at age 14, teaching people about the tide pools, and I really have not stopped to look back. It's been pretty incredible and pretty magical to get to see the world through the lens of either teaching about the ocean or conducting research on the ocean. And it's been a wild ride. That said, we do it for the memories, we do it for the ocean, but also we do it for the gram. So here's some of my favorite photos from fieldwork. The picture of me holding the fish is a sea raven conducted when I was working for NOAA as a contractor with a different organization where I was working at sea doing trawl surveys. That's a sea raven. The sea turtle photo is a nesting loggerhead in Miami, Florida. This photo is taken using long exposure, no lights on the turtle. It's really not great for them, but it's been really cool and really fun to be able to explore our oceans in this way. I've taken otoliths. I've gotten to assist in both fisheries dependent and independent monitoring, which allows us to understand what's happening with our fisheries offshore at a lot of different levels. I've worked at the county, state, and am contracting on the federal level now. So I've seen a lot of different government work. I've worked with nonprofits. It's been quite a journey, but I am working my dream job here at NOAA as a contractor. So just to dive in, what exactly is NOAA? This audience knows better than most probably what NOAA is, but in case you don't, we'll all start on the same page. We are the National Oceanic and Atmospheric Administration. Our reach goes from the surface of the sun to the depths of the ocean floor as we work to keep the public informed of the changing environment around them. As of March 2025, we have 12,000 personnel worldwide, and 6,773 of those are scientists and engineers. NOAA's mission is science, service, and stewardship. So the goal is to understand and predict changes in climate, weather, oceans, and coasts, to share that knowledge and information with others, and to conserve and manage coastal and marine ecosystems and resources. Given that we have such a wide range of wants, needs, and desires, of course, NOAA has to be divided further. I don't work with 12,000 other people. I do, but not on a day-to-day basis. So we're divided up into 6 line offices. I work within NOAA Fisheries, so that is, of course, the one that came first. NESDIS, which I saw you had a presentation by last year, stands for the National Environmental Satellite Data and Information Service. We have NOAA Research, which encompasses the Office of Oceanic and Atmospheric Research. The nifty logo with the plane and the boat is the Office of Marine and Aviation Operations. They are the only ones without words. And the National Weather Service, which we all hear a lot about and rely on for data, especially when we're spending time on the water. And of course, the National Ocean Service, which represents that's where the National Marine Sanctuaries live, as well as where the charts get made here at NOAA. So to continue kind of honing in on where I am and what my role is at NOAA and how I work with endangered species, we kind of have to keep zooming in on what's happening. And so NOAA Fisheries is the office in which I work, where they are responsible for the stewardship of the nation's ocean resources and their habitat. We provide vital services for the nation, all backed by sound science and an ecosystem-based approach to management. This includes productive and sustainable fisheries, safe sources of seafood, recovery and conservation of protected resources, and healthy ecosystems. For NOAA fisheries, we have many different regions. As you can see, hopefully wherever you're tuning in from has a NOAA fisheries office close-ish to where you are. But we cover a significant portion of the country, and there are so many places that have, we have our headquarters, but we also have, other offices, satellite campuses, if you will, that may be close to where you are, which I think is really neat. And it's cool to see how much of the country is encompassed by the various fisheries offices. So within NOAA Fisheries, I work within the Protected Resources Division at the Greater Atlantic Regional Fisheries Office. We work to recover and conserve protected species. So we work under the mandate of the Endangered Species Act, which protects against trade of international endangered species, and of course the Marine Mammal Protection Act, which protects all mammals that rely on the ocean. So this includes whales, dolphins, porpoises, seals, sea lions, manatees, sea otters, walrus, and of course polar bears. There are heaps of species that are protected under the Marine Mammal Protection Act. And for later learning, if you are so interested and so inclined, we do have a directory for endangered species and threatened species that are protected by NOAA. And this includes a list of over 150 species, which is very exciting. So when we come down to my work with NOAA, I work within the Protected Species Conservation Branch, and we work with a number of different endangered species across my team, but I spend the majority of my time thinking about and talking about the North Atlantic right whale. So North Atlantic right whales are beautiful, amazing, wonderful whales, in my opinion. And they are they're present along the East Coast. But I would be remiss not to point out, since we have potentially viewers from the West Coast and the East Coast, that the West Coast does have their own right whale, a population called the North Pacific right whale. And while this talk is going to be focused on the North Atlantic right whale, a lot of the same stressors and features or things that have happened to North Atlantic right whales have also occurred with North Pacific right whales. From here on out, I will probably be referring to them as right whales, and you can just assume that I'm talking about the North Atlantic right whale. So they are aptly named the North Atlantic right whale because they spend, the majority of their time in the North Atlantic. These days, the right whale's range is more limited than this would suggest, at least as far as we know. They spend the majority of their time between Northeast Florida and about Southeast Canada. So that's kind of a historic range map. But for those who are unfamiliar with right whales, and frankly, I didn't know a whole lot about them when I started this role, I figured we could all get to know these whales together. North Atlantic right whales grow up to 52 feet. They can live 70 plus years. We don't actually know the upper limit of their age at this time, and they can weigh up to 140,000 pounds. They are very large animals, but they're also very tactile. This photo that you see is a mother right whale cradling her calf in her pectoral fins, which I just could not give this presentation without showing because I just think it's an amazing photo that the Clearwater Marine Aquarium managed to capture this year in the calving season. We're going to do a quick run through the identifying features, and we're going to compare those to another whale so that we can really lock in and see what we're talking about. Right whales lack a dorsal fin. They have short, stumpy pectoral flippers. They have a dark and smooth tail. They have a diagnostic V-shaped blow, and they have white patches, which are called callosities, on their head. So they lack a dorsal fin, and having something be identified by its lack is a little bit difficult to demonstrate. So I thought I'd include humpback whales as a comparison for our species today. Humpbacks are kind of the iconic whale. When you think of a whale, it's usually a humpback, or at least for me it is. And they have a worldwide distribution. So they're actually a really good example. In addition to being worldwide, they also are about the same length. They grow up to around 50, 52 feet like that right whale. And so they have similar sizing and kind of similar scale that we can compare to. So the dorsal fin that humpback whales and a lot of other whales have is on their back, whereas right whales lack that. So they have this big, broad, flat, dark back. So that's one diagnostic characteristic of them. In addition, they have teeny tiny pectoral flippers as compared with their bodies. Humpback whales have really large ones compared with their bodies, and they're very white, typically. So this is a good comparison to kind of see. Again, these whales are approximately the same size, and those pectoral fins look so different. In addition, they have very different tail shapes. So right whales have smooth, dark flukes, which means, the entire fluke, that tail, is black. And that edge, so the bottom part of the tail that you can see, like the top of the photo, is really, really smooth, where humpbacks have kind of a rough edge on the edge of their fluke. And also they typically have, white or can have different patterns. So that's what we mean when we say smooth, dark flukes. In addition, right whales have this lovely V-shaped blow. Kind of tough to see when you're out on the water, and we'll get into why they can be difficult to see in a bit. But right whales have this wonderful V-shaped blow, and that bottom picture is actually a picture of a North Pacific right whale, just showing exactly that V-shaped blow. Meanwhile, humpback whale blow is a little bit more dispersed, and it's a little bit shorter than that diagnostic shape for the right whale. In addition to our other characteristics, right whales have what are called callosities. And what's neat about the callosities is they are individual to each whale. So each whale will have a different callosity pattern than others. And we can use these to identify the whales themselves. And as part of our identification of them, we name or nickname some of the whales. And we have names competitions every year through the North Atlantic Right Whale Consortium, and the public actually can suggest names for the whales that get named every year. And so the whale on the right has a callosity pattern just ahead of the blowholes that looks like a snow cone. So that whale's name is snow cone. And the whale on the left, which I think is a little bit more of a stretch, her name is Fenway. And her callosity pattern that is at the top of her rostrum, so what we're just looking straight down at, scientists or the public thought looked like a baseball bat. And since a lot of the researchers who study right whales are based out of Massachusetts, the whale is named Fenway after Fenway Park, where the Red Sox play. So she's got a baseball bat, so she is named for a baseball park, which I think is fun. Some of the names are awesome, and some of the names are sometimes a little bit strange, but they're all creative and named, I think, by the public. So this does beg the question, why are they called the right whale? Right whales' names comes from the late 1700s because they were considered the right whale to kill by whalers. Kind of a grim name for this species. They were considered the right whale for a whole bunch of reasons. They are typically slow moving. They remain at the surface for extended periods of time. They're kind of picky eaters, which is fun fact. I'm a vegetarian. These whales only like one type of plankton called copepods. I think it's just a little connection point. But because their prey is at the surface generally, they spend a lot of time at the surface as well. In addition to spending a lot of time at the surface, they inhabit coastal and shelf waters. So they're pretty close to shore. So the whalers wouldn't have to go as far to hunt these whales. In addition to this, they float when they're dead, which is an benefit when you are a whaler trying to process a whale at sea. They also have the unique behavior that they don't really swim away from boats, which again makes it really easy if you're trying to go up and hunt a whale and it doesn't run away from you or swim away from you, as the case may be. They also have the second longest baleen plates of any whale species. Their baleen plates can be 8 to 10 feet in length, and they can have up to 500 plates of baleen in their mouth. Why the baleen matters is because back in the whaling days, before we had plastic, we used baleen as in a lot of things that you would use plastic in these days. They were used as boning in corsets as well as in umbrellas back in the 1800s. In addition, they have very thick blubber, which can be over a foot thick. And that in and of itself yields a lot of oil. So overall, these whales were very, very profitable to whalers. And so these whales were hunted to near extinction. And a moratorium was put on whaling them because, they were hunted to, again, near extinction. The population estimate for the North Atlantic right whale was that there were less than 100 when they stopped whaling them. It's not all doom and gloom. It can't all be doom and gloom. We're here to talk about endangered species, and we're here to talk about how we're trying to help them. But the North Atlantic right whale has had some growth and decline in their population since the early 2000s. This graph shows the population status throughout the years since the year 2000. Currently, we estimate that there are about 370 individuals that are alive. Roughly 70 of these are reproductively active females. This is important because obviously we can only have calves as we have reproductively active females and aged females. And these whales have a very slow reproduction time where they will have many years between calves. And so females having calves is essential to their recovery as a species. As you can see, there is a grayed out event on the chart. This is since 2017, an unusual mortality event, or an UME, has been declared. Under the Marine Mammal Protection Act, a UME is defined as a stranding that is unexpected, involves a significant die-off of any marine mammal population, and demands immediate response. Beginning in 2017, there were elevated mortalities in North Atlantic right whales that were documented in Canada and the United States. It is worth noting that the preliminary cause of mortality, serious injury, and morbidity, which includes sublethal injury and illness in most of these whales, is from rope entanglements or vessel strikes. That said, every mortality that we have been able to determine the cause of death for the whales since 2017 has been human caused. Just to prepare viewers, there is a graphic picture, or two graphic pictures in the next slide. Just so that you're aware, please look away and I'll let you know when you can look back if you are squeamish. There are two primary threats to the North Atlantic right whale. These include vessel strike and entanglement. And as we said, these are the leading causes of death for this species at this time. Vessel strike can appear in lacerations from propeller impacts with propellers, which you can see here, in addition to severe blunt force trauma that can be caused by collisions with the hull of vessels. Entanglement largely occurs with crab and lobster pot traps in the ocean. So we will move on from our doom and gloom. If you looked away, we are past the graphic photos and you are welcome to rejoin us. We have, of course, a plan to help get the whales back on the up and up and trying to help them recover as a species. So in order to do this, we have two main steps. We want to monitor the progress of the whales and we want to address the threats to the whales. So how we do that is we employ many different tools to try to understand what is happening with our right whales. We conduct aerial surveys from airplanes with NOAA Fisheries and other partners that we have who are out looking for whales in places that we expect them to be and sometimes places where we don't expect them to be. We also have vessel surveys where people on board ships are out on research vessels looking for right whales in the ocean and trying to document what they're doing and where they are. We have passive acoustic monitoring, which you can see examples of in the lower part of the slide. These include acoustic buoys and gliders, both of which are listening for right whale communication. And so when they speak to one another, these devices can record that and transfer that information to scientists who can then let people like me know to get the word out about the right whales. We also have a reporting hotline, which if you are in the Northeast, which includes Maine down to Virginia, that phone number is here on the slide. But if you are elsewhere and spot an endangered or a sick or injured marine mammal, you can look at the link that's on this PowerPoint and go and see what the stranding phone number is in your area. But our reporting hotline also takes in phone calls and announcements of North Atlantic right whales. We want to know about every single whale that gets seen because there are so few of them. And we get help from the public and recreational boaters and commercial boaters alike, who also tell us when they see whales out in the ocean. So after monitoring them and understanding what's happening, we have to address the threats to right whales. And as I said before, there are two main threats to right whales. We have vessel strike and entanglement. The photo at the bottom with the horizontal shot is a whale towing a crab pot with it. This whale swam for hundreds of miles with this gear attached. And this whale on the right is accordion. She was named for that scar on her back, which is supposed to look like an accordion, I guess. And that is from a vessel strike that she had when she was younger. Happily, she was a mother of a calf this year, so that was some good news for us. So to reduce entanglement, this is what we are trying to prevent. Very accurately depicts what happens when there are vertical lines in the water. The whales can swim through them when they are diving or, cruising at the surface. And when they get entangled in gear, they tend to kind of really get themselves muddled up and really entangled in the gear. So they really end up pretty tangled when we see them. That said, we are trying to help prevent that. And so we work with fishermen and we are working to improve safety for the whales and improve, decrease gear loss for our fishermen. So we do that by modifying the gear as one way. We have weak inserts and weak lines, which are designed to help break when a whale swims through to help reduce the chance of entanglement. We also have what's called gear marking, so we can determine where the gear was, where the whale was entangled to try to understand what's happening there. We can increase trawl length, which reduces the number of vertical lines in the water, and those vertical lines, again, are the problem for these whales. And in addition to that, we can close fisheries when there is high overlap with whale use of that area. So reducing, the overlap of fishing gear in the water and whales in the water. Another technological solution that we are working on is on-demand fishing. So on-demand fishing gear is being developed in collaboration with the fishermen that would be using it. The fishermen provide input on design and they are testing the different configurations. And so we have a few different configurations that allow no vertical lines to be present in the water. And when a fisherman comes back to retrieve their catch, they can essentially, click a button and have their gear brought up to them from the ocean floor. And that helps reduce entanglement by having the whales not have any vertical lines that they need to be around or be near, which is very exciting. And I think a really neat technological advance that we are getting to see in real time. So the other part of the threats to right whales is reducing vessel strike. This is where I work as the Mid-Atlantic Large Whale Ship Strike Reduction Liaison. I am helping to try to reduce ship strike to right whales. And we do this in a few different ways. We have approach restrictions. We have speed restrictions. We are exploring new technologies to help reduce vessel strike. And of course, we have outreach, much like we're doing here today. So by law, you are required to stay 500 yards away from right whales. That is a NOAA law. It's a federal law. And in order to get close to take these sorts of photos, you do need a federal research permit. So, it's all fun and games to say, haha, we have to stay 500 yards away, but unfortunately, these whales are very difficult to detect. And the reality is these dark gray whales typically swimming in the North Atlantic, which is pretty murky, pretty gray, makes it really, really hard to detect them because they don't have that dorsal fin. They're not super active at the surface all the time, but they are frequently at or just below the surface. And so if you're close to a whale that you don't know what it is, it's safest to put the engine in neutral and either move away when you know where the whale is relative to your boat, or let the whale move away from you. Again, if you manage to identify it and it is a right whale, please call it in. This is especially true on the West Coast. They don't know a lot about the movements of the North Pacific right whale, but we really do want to hear about it on the East Coast too. We're just trying to figure out where they're utilizing their habitat. And yeah, this is a good law to help protect the whales as best we can. In addition to approach regulations, we have speed restrictions. The seasonal management areas, which are shown on the left, are areas that require vessels 65 feet and greater to go 10 knots or slower during certain times of the year. And so what this allows is by going 10 knots, it significantly reduces the risk of mortality for right whales if there is a collision. But in addition to that, it allows the operator of the vessel more time to respond safely and maneuver their vessel if they do detect a right whale. And the time of year that each of these SMAs or seasonal management areas is on reflects approximately when those whales are expected to be in that area or moving through that area. Because we can't ask the whales to stay in their nice little boxes, we also have voluntary measures, which include our dynamic management areas and our acoustic slow zones. So dynamic management areas are triggered by a visual observation of 3 or more whales in one area, while acoustic detections are defined by a confirmed right whale call. In either a glider or a passive acoustic buoy or a moored buoy. And so these yellow boxes indicate places where we've had either a visual or acoustic detection of whales. This was earlier this year. We had many, many, many slow zones along the East Coast, and these reflected areas where we were certain there were right whales in the area. And in these slow zones, we ask that boaters slow down to 10 knots or less to protect these right whales. These are voluntary measures as compared with the seasonal management areas, but you get the idea of slowing down really helps the whales. So we have restrictions, we have approach regulations, but we also have outreach. That's me on the right. We are working at a boat show in Atlantic City trying to raise awareness about the right whale because not everybody knows that right whales live in their area. And not everybody knows that they are boating at the same time that right whales may or may not be passing through their, happy boating ground. So we also use social media. You can connect with us on Facebook and or Instagram to hear updates about our North Atlantic right whales and what's happening with our slow zones and seasonal management areas. We provide information to the public at events like this and talks. And we also are exploring new technology to try and help reduce the risk of vessel strike for North Atlantic right whales. One of the ways that we're doing that right now is we have a partnership with a company called Motion Info and a nonprofit called the International Fund for Animal Welfare. And we are using AIS, which, if you're not familiar, is like a GPS tracker for boats that vessels larger than 65 feet are required to carry, though many smaller vessels do carry them as well for safety. And so what the man behind Motion Info came up with was a way using these station keepers and putting them near the entrances and the shoreside of our seasonal management areas and using them to contact boats that are 65 feet or greater and fall under the jurisdiction of our seasonal management areas if they're speeding in our in our seasonal management areas. And so the station keeper will essentially talk to their AIS plotter, like you can see in the Garmin image, and it'll pop up a message that says, 10 knots or slower, sort of like speed signs outside schools where it says 25 miles an hour flashing. And so this is a way that we're trying to reduce vessel strike because we're trying to get people who are sometimes unaware of the law, follow it in the seasonal management areas where it is required that they abide by these rules. Our final bit of outreach that I'd like to talk with you about tonight is our Whale Sense program, which is a voluntary education and recognition program offered to commercial whale watching companies. We have operators in Maine through Virginia and also Alaska that hold themselves to a higher standard than the Whale Watch regional guidelines. And so these operators are trained on how to identify species in their area. And frequently, our Whale Sense operators here on the East Coast have been known to call in and tell us about right whale sightings that we wouldn't have known about previously, which is very exciting. And they've also helped us find stranded and injured marine life as well. In addition, we have a program called See a Spout, Watch Out, which is dedicated to preparing boaters and sailors in the greater Atlantic, again, Maine through Virginia, to navigate safely through the waters shared with protected species and helping them understand, what could be around and what they need to watch out for in order to boat safely and operate their vessels safely in, our shared ecosystem and in our shared oceans. So that's kind of the end of my right whale talk. But since this is a, career building moment, I thought that I would talk about how you too can work in marine science. Almost anything that you can do within the STEAM category can be applied to the ocean. We need coders, software developers, database managers, engineers, computer scientists, biologists, physicists, mathematicians, meteorologists, but we also need science communicators, communication specialists, artists, graphic designers. If you can think about it, it can be applied to the ocean. And I think that it's important to remember that hard work pays off. Going through a science degree can be grueling at times, and you might be asking yourself, why am I learning the genus and species of, every plant on campus, staying up late? But it's worth it in the end, to be able to do what you've dreamed about and to be able to make a difference for our, planet, for our oceans. That hard work does pay off in the end. It's so worth it. Be open to step outside your comfort zone. I have moved to places I've never been before for work because I wanted to see what it was like. And I've worked in fields with animals that I never thought I would. I'm a biologist, so it makes sense that I'm working with animals, but trying new things can really open your mind to a new realm of possibilities and a job that maybe you hadn't thought of or hadn't even dreamed of before. I only dreamed of working with whales as a kid, and here I am doing it, a couple of decades later. Don't be afraid to ask for help and or guidance. This is a step that I wish someone had told me years before I figured it out for myself. If there's a scientist doing what you want to do, don't be afraid to reach out. Most scientists I know are excited, ecstatic even, to talk about what we work on. I have told so many people in the DC area about right whales when we are 2 hours from the beach at the closest. There is a small army of people who know about these whales who may or may not ever see one in their lifetime. But that said, everyone almost is ready to talk about and at least describe how they ended up where they were. And not everyone has had a straight shot into their job. A lot of us have meandered and found what has made sense and what hasn't been a good fit for us. I also like to say that a positive attitude and a little tenacity can go a long way. It's not all daisies and roses. It can be, especially in field work, grueling long hours in the hot sun or the cold, or long hours, into the night. It can be gross, and it's so worth it. I love what I do. And get your foot in the door with volunteering early if you are in middle or high school. Being able to say that you have experience before you've gotten to college can really only help your applications. And some of the things that I learned when I was volunteering in high school, I still use today. And there are things that have stuck with me all these years later. And if you're entering university, talk to your professors about opportunities. I promise they're not as scary as they seem, and they can really help you kind of jumpstart your career or figure out what you like and don't like. I hate staring into microscopes. I won't do it. And I learned that by working in a lab where I had to do that. And I said, this is not for me. And I'm so glad that I learned that early on and didn't try to go get a master's or a PhD in something that would have required that. So, having experience early on and learning what you like and don't like is as important as knowing what you want, if not more so that you can kind of tailor your path to match what you're looking for. And as the meme says, there are many benefits to being a marine biologist. Thank you so much for your time. does anyone have any questions? And of course, if anyone has questions after the presentation, I would be more than happy to answer any questions. My email is at the end of the presentation.
All right. Well, thank you, Briana, for such a wonderful and thorough presentation and ending on a very inspirational note. I hope that, you know, we're gaining many future scientists out of this tech talk. That's wonderful.
That's all I hope for.
Clearly, you're passionate about your job, and it shows. First kind of question, regarding whale strikes. Is there something about the right whale, their behavior, their social behavior that makes them more likely to be hit by a ship at surface level? I'm not a marine biologist, and when I think of this, I think big ocean, and whales are huge animals, but big ocean. And in the grand scheme, a ship and a whale are very small in comparison. So are they playful? Do they like to follow ships? Is there something about them?
Yeah, so that's a really good question. In the grand scheme of space and the ocean, it is crazy to think about the fact that whale strikes happen, and it's not just right whales. All whale species get hit by boats, which blows my mind, or at least all baleen whale species have had interactions with whale strikes, vessel strikes. And the part of the problem is that for right whales specifically, they're very difficult to detect. That dark gray body in dark gray water makes them very hard to see. We have some great resources online that show surface level photos of right whales feeding, actually in our Sea Spout course, which anyone can take. You do not have to be on the East Coast in Maine through Virginia to take it. And we have a video of right whales skim feeding at the surface, and I think there's a photo of it. And I know there are 3 whales in the photo, and I can only find 2 reliably, because they're right below the surface and they really blend in with that water. In addition, they do spend a lot of their time close to the coast. They've been migrating since before engines were a thing in vessels. They've been making this migration for thousands of years. And so having, this biological instruction essentially to stay shallow and to stay close to the coast. They've been called the urban whale before because they migrate really close to the shore, and the East Coast has an incredibly high concentration of vessels moving in and out. And I do think it's important that we acknowledge that vessels of any size can hit a right whale. It's not just these large ocean going vessels. We have, record of smaller vessels hitting right whales as well. And, I think something else that's tough is that when smaller vessels hit these 60-ton animals, it's not just that the whale is dying, which is absolutely a tragedy and very, very hard on this population that's struggling to recover, but also can be very dangerous for the people on board the vessel, and it totaled a boat in Florida a few years ago that they were lucky enough to be able to get the boat over to a sandbar, but your boat could sink. So it can become a very dangerous situation for both the whales and the people involved, which is scary. But yeah, they hug the coast. They're really tough to see. They don't always move in large groups. When they're in surface aggregations, they can be very active, but they're not always traveling in large groups. So it can be, one whale or a couple, like a mom and calf. So there's that. In addition, our oceans are getting louder with the increase in vessel traffic, which has happened over the last few decades. And so part of that is, being able to hear where the vessel is can be difficult for these whales because there are vessels in all directions a lot of the time. So that can be an issue for them too. So it's not like they're chasing boats or anything. They're just slow moving and really hard to see.
That's a really helpful answer. Personally, my own question, I was going to ask if whale strikes were a concern for recreational boaters, saying someone heading out to the ocean to fish for a day. But I think the answer is yes, from what you said.
Absolutely. The other part is it's not just right whales. Whales can be really unpredictable when they are feeding and when they are doing their whale thing. So, there was a video that circulated not too long ago, in the last year for sure, of a humpback whale breaching and kind of coming down on top of a recreational vessel that was fishing nearby, and it flipped the boat and threw two fishermen into really cold, Gulf of Maine water. And so that can be a safety issue immediately. But also, yeah, they're very large and they are not super concerned about a 20-foot vessel because they're doing their whale thing. So yeah, it can definitely be a wreck boater problem too. And we talk a lot about that in our Sea Spout course because I've boated in, East Coast waters when right whales were present, and I had no idea. I was sailing, and I had no idea that there were whales in the area because I was living in Miami at the time, and there aren't a ton of whales that hang out down there. So, part of doing outreach events like this, and part of my passion in science communication, is just raising awareness, because that's a huge part.
Yeah, so you gave some resources to report a whale sighting, right? To call it in or go on the website to report the whale sighting. And there may be some future commercial captains out here, but for many of us recreational boaters, is there any specific advice if you're out on the ocean and you do spot a whale, or as you said, an aggregation, there are several, and you're in a small boat? Is it like a matter of giving space? Should you head out? Is it that simple?
Yeah. So yeah, giving space is a great way to reduce interactions between whales and vessels. Obviously, with our right whales, we have our 500-yard approach rule. Don't get close to them. It's 500 yards is a long ways away. So if a whale surprises you, you can always throw your engine in neutral and wait until you kind of get a sense of. Sometimes the whales are just passing through and they'll cruise right on by you. Other times, if you kind of get a sense that they're hanging out in the area and you have a good idea of where they are, you can move away. We don't recommend reversing out because that changing in the gear and something about that can be more like distressing to the animals. But the Sea Spout website has all kinds of advice about how to safely be out on the water and observe whales, or what to do if you are surprised by whales, because even though it's a big ocean, they still pop up. It's kind of crazy how animals that are so large can just sneak up on you.
And we have another question coming in about submarines. Do submarine communications, ELF communications, do they impact the right whales or how whales communicate in general?
That is a great question. I learned moderately late in my science career, as far as things go, that it's okay to say I don't know. And since I don't know what ELF communications are, and I don't work with subsurface sound, I am going to go ahead and punt that into the I do not know category.
That's fair enough.
Someone, probably the Navy, has done research on that. They do a lot of marine research as well. But I work with ships that are at the surface. Sorry.
Well, I'll go back to, we might get clarification on that, and it might ring a bell for you. But I appreciate the honesty, something to look into. But I'll go back into something else from the presentation. So you mentioned some of the new technologies that are being used to track and monitor the right whale, and flyovers, aerial observation, drones. But you mentioned passive acoustic buoys. So for anyone that doesn't know, what is that? What does it do? And how does that help you monitor the whales?
Yeah, this is a great question. I love passive acoustic monitoring. I think it is so neat. Hydrophones are essentially underwater microphones that just listen for what's happening in the ocean. And so we have a solid set of acoustic hydrophones that are either moored to the bottom of the ocean or attached to these like gliders and buoys that exist up and down the East Coast. And so what's really interesting about marine life that communicates in the ocean, such as marine mammals like whales, they have a lot of signature sounds that they make. Something that's really, really neat is the North Pacific right whale specifically is documented making what we call a gunshot call. And so NOAA Fisheries actually on our website, I'm pretty sure it's our website, you can actually listen to the different calls that different species of whales make. And so that allows you to kind of hear with your ears what it sounds like on the hydrophone and what those have been recorded using hydrophones. And so we have different types of buoys that, just sit and listen. They're listening in the ocean to what's happening. And so if we hear a noise that we think is a right whale, a specialist will, essentially confirm that yes, this is a right whale, or no, we don't know what that is. It's too garbled. And so if it's a confirmed right whale, we create a slow zone based on that. And the gliders, so the ones that are attached to moving autonomous vehicles, we actually submit their data to satellites, which can be broadcast back to shore as people like me working at a desk now can figure out whether or not that's a whale. And it doesn't require us to be out in inclement weather. It doesn't require, working at sea is really expensive. We can just send out a piece of technology that can just go and listen for us. And kind of spying feels a little insidious, but like listening in on what's happening in the ocean, and kind of eavesdropping on what's happening down there, which I think is so neat. And yeah, it's such a cool piece of technology, and I am so obsessed with it.
That is really interesting. But I have to go check out the whale calls.
They're amazing, and it's super, super neat. Right whales also make what are called up calls. And I do that because the sonograph, which is the, visual readout of the sounds that are happening, it makes a nice little like check mark almost of just like the whale making that noise. And it's so cool. Right whales make really interesting noise. And they're super neat.
It's great. We did get a little clarification. Let's see if it on the ELF communications. Sonar text would call it, I hope I say this right, biologics.
I don't know
anything
about that. I'm gonna be honest. And here's the other problem is I am new relatively to the whale scene, if you will. I studied fisheries management, and fish care a lot less about sound than marine mammals do. Famously, they like things that float and provide structure. So, oil rigs are super loud and fish flock to them. So my understanding of fish sound comes from like the way that fish communicate, because fish also do use sound. Some fish use sound to communicate, but I don't know anything or enough about submarine noise and marine mammals to speak with any confidence on it. But thank you. I'm gonna go look into that personally.
Biologics.
After this.
All right. Now we're almost out of time. So one last question here. Does NOAA use any type of physical tracker, say like a radio frequency type tracker embedded into whales, like, other animals are tracked that way? And if they don't, how do you know it's the same whale in migration?
This is a great question, and this is a question we get from the public a lot. We're saying there's 370 of them. That's really not that many. We're really worried about them. Why don't we know where they are at all points in time? Why don't we just stick them with a tracker? That foot of blubber that we talked about is a big hindrance to physical tags.
So you don't use physical tags. I just wanted to clarify
we use
that.
Suction cup tags occasionally. And so those don't stay on for long periods of time. We know it's the same individual because when they're babies, their callosities don't really exist yet. And so it takes a few years for their callosities to kind of like become the shape that they will be for the rest of their lives. But we can identify whales reliably using their callosities. And we also do take biological samples from them when they are in the calving grounds. And I think also in Cape Cod, because they hang out in Cape Cod. And so we do collect data on these whales, and we have, DNA evidence to say like, this is this whale is, this whale's calf. These whales are related. This is the father of this whale, which is really neat. And really exciting in a field like ours where, they're stuck underwater, and we are famously not well equipped to be underwater like that. But the physical tag problem is really one of the risk of infection is very high for this endangered species, that we don't want to be getting all of our whales sick. That is very risky when we can afford to lose less than one individual whale a year for the biological model, for their recovery. In addition to that, blubber is so thick and like oily that tags actually slide out, which is really gross. But also what I learned recently when we were talking about this the last time. So it's a very good question. And it was also an immediate question of mine, but they're just not great candidates. Other whales, I think it's easier to tag, and for other marine species, absolutely. But right whales are just a unique band of tough to get all the information that we want from them, and we still can't talk to them and ask them. So kind of tough. But yeah, thank you again for having me, and thank you for being a receptive audience, and thank you for your great questions.
Absolutely. And we'd all like to thank you for sharing your passion in marine biology with all of us here. And we hope everyone in the audience will join us on June 24th for Aquatic Robots. Thank you very much, Briana.
Thank you.
Thank you much.